Hi friends, now we are going to study something about the strength of a joint. When we are talking about the strength of a joint, there are three factors that is to be taken into consideration. One is the tensile strength, second is the shear strength, and third the bearing strength. I will try to explain the thing by taking one simple example of a lap joint of 150 mm plate width and 10 mm thick, and when it is an overlap there are two bolts of 16 mm placed at a pitch of 100 mm with an edge distance as 25 mm. Now we have to find out the strength of this joint. First of all, when we are talking about the joint, the first is the tensile strength of a plate. We'll discuss something about the tensile strength of a plate. Before we should proceed, some important parameters that is to be taken into consideration. The diameter of the bolt I have taken as 16 mm. Width of the plate B is taken as 150 mm. Thickness of plate as 10 mm. Gamma M0 is taken as 1.1 and gamma M1 is taken as 1.25. Similarly, Fu is taken as 410 Newton per mm square and FUB is taken as 400 Newton per mm square, like this. First of all, we start with the tensile strength of a plate. We are considering only the single plates, these plates of width 150 mm. How many holes were there? There are two holes. So what is the net width? And then multiplied by the thickness will give the net area of that plate. And multiplied by the stress will give the value of tensile stress of a plate. The mathematical expression already given in a code also, that TDN is equal to tensile design strength of the plate, which is denoted by capital TDN, 0.9 AN FU upon gamma M1. What is AN? And the net plate area. Net plate area. Net plate area means net width multiplied by the thickness of plate. That is called the net plate area. How many bolts are there? 2. What is the diameter? 16. What is the overall depth of the hole? It is 16 plus 2, that is 30. Now, first of all, we try to calculate the net area. B minus n times D0 into T. N is the number of bolts, D0 is the diameter of a hole. 150 minus 2 into 18 into 10, that will give 1140 mm square is the AN. Substituting this value over in this mathematical expression, 0.9 into 410 upon 1.25, this much Newton, or we can convert it into kilonewton, it is 336.52 kilonewton. This is the tensile strength of a plate. Now we'll go for the next part, that the design shear strength of a bolt. This expression that I have written over here, you can be seen in the IS code also, which is written as VDSB, that is design shear force of a bolt. VDSB, design shear force of a bolt, is equal to net shear force of a bolt, nominal shear force, the shear of stress of a bolt upon gamma M1. This mathematical expression already given in IS code 800/2007 and which is allowed in examination also. Now VBSB, VNPB, VDPB, then VNSB. VNSB is equal to FUB upon root 3 and N into ANB plus NS into ASB. I will explain each and every one. This is the shear strength of a bolt, which is already I have mentioned over there. It is taken as 400 under root 3 and N, number of plane of failures and AN is the net area of a threaded portion of a bolt. NS is the number of plane of failure in a case of a shank. And ASB, the area of a shank, that is bolt. As per the code, it has already mentioned that A and B is equal to 0.78 times pi by 4 d square. Pi by 4 d square. For a lap joint, an N is taken as 1 and an S is taken as 0. But for a butt joint, an N is also taken as 1 as well as an S is also taken as 1. Means the plate is failure at the shank level also and it is failure at the bolt level also. So at that time when it is a butt joint, both N and NS will be taken as 1, 1. But when it is lap joint, the failure of shank will not take place, only the failure of the bolt will take place over here because of the shear. So NN will be taken as 1. This is the important point that is to be taken into consideration. Substituting this value over here, 400 upon under root 3, 1.785 by 4 into 16 plus, because an S is 0, so it comes out to be 0. And it comes out to be 36.2 kilonewton. This is VNSB. We are supposed to find the design strength. So it is nothing but under root of VNSB this much and VDSB upon gamma M1 which is 1.25. It comes out to 28.97 kilonewton. Design strength will be 28. For the shear it will be 28.97. Third one. First, for the plate. Second, for the bolt, that is for the shear. And third, for the bearing strength of a plate, of the bolt. Design strength in a bearing. VDPB is equal to VNPB upon gamma M1. Here P indicates the bearing strength of a bolt. S denotes for the shear and here the P denotes for the bearing. So VDPB is equal to VNPB upon gamma M1 and VNPB is taken as 2.5 kb dt into Fu. What is kb? It's a constant. And this constant can be calculated upon the 4 factors, and out of the 4 factors, whichever the least will be taken as value of kb. Just like kb can be calculated with E upon 3 times d0 or P upon 3 times d0 minus 0.25 and FUB upon FU and 1. Substitute the value of all the 4. This comes out to be E is 25 upon 3 times 18. P is again 100. So 3 upon 18 minus 0.25. FUB, I have already told it is 400. This is 410. 1, which is the least? Definitely 0.46 is the least one. So KB will be taken as 0.46. Substituting a value over here, you can find it comes out 2.5 KB dt Fu upon gamma M1, that is 1.25. This value comes out to be 60.35 kilonewton. What is the strength of a joint? There are 3 parameters just to calculate the value. First about 336 point something, then next 28.97 and third one is 60.31 kilonewton. Then what is the strength? The strength of the joint is nothing but the least of the tensile strength, shearing strength and the bearing strength. Here, whichever the least will be taken as the shearing strength of the beam, because once if it fails at 28.97, it can't reach up to this and this. So this is to be taken as the least, that is the shear strength of a bolt or shear strength of a joint. Here I already mentioned over here the least of the following, and one important thing, the least of the shearing and bearing which is related to the bolt, is called bolt value, is known as bolt value. The design strength of the shearing and design strength of the bearing में से जो least है, that we call as a bolt value, and out of the three, tearing, tensile, shearing and the bearing, out of the three, whichever is the least is known as a strength of a joint. I think if any doubt, this problem will have a very clear-cut idea, and all the mathematical expression are already mentioned over there in the code, and we'll try to solve few more problems over here, and for this video I think this is okay. Thank you very much.